All right, so we've been talking about solving equations and solving equations in one variable, trying to find out what the value of that variable is. That makes the equation true. And we want to extend that and talk about literal equations and some more specific forms of literal equations like formulas. Okay, we want to be able to rewrite and use literal equations and formulas. That's the point of today. So I guess what we need to know is, what is a literal equation? Well, literal equation is an equation that involves two or more variables. So we're not just going to have one variable anymore. We're going to have more than one. And like I said, a lot of literal equations are formulas, and there are formulas, and a formula is an equation that states a relationship among quantities, and there are a lot of formulas that you've seen before, and those are the ones that we're going to work with today. So like I said, formulas are special types of literal equations. One thing you want to keep in mind is that very often different formulas will use the same variable, but they'll mean different things. Like, for example, here, c equals 2 pi r is the circumference of a circle, and so c means circumference. But in the second formula here, c equals 5/9 times f minus 32, that's how we convert from Celsius to Fahrenheit and Fahrenheit to Celsius. And so c doesn't mean circumference anymore, it means Celsius. So one thing you do want to be careful of is that you understand what the variables stand for in your formulas, in your literal equations. Okay? Here are some of the more common formulas that you'll see used a lot, and that we're going to work with a lot here in the notes and the homework and those kinds of things. All right, so you got your perimeter of a rectangle, circumference of a circle, area of a rectangle, area of a triangle, area of a circle, distance traveled, and then temperature. So make sure you get those in. And not necessarily that you have to memorize these formulas, but at least be familiar with them. You'll see them a lot on the PSAT, ISTEP, NWEA tests, all that kind of stuff. So just be familiar with what those formulas look like and the variables that are in them. Now, to solve a literal equation, it's not going to be the same as solving an equation. Okay? We're going to do this the same way we solve any equation, but we're not going to actually look for a numerical value. Okay? We're going to have too many variables for that. We're just trying to make it take a literal equation and make it look different. Okay? But the steps are the same. The first thing we're going to do is we're going to identify the term containing the desired variable, right? Whatever variable we want to get by itself, whatever variable we want to isolate, we're going to go find that term first, that entire term that has that variable in it. Once we find that, we're going to undo any addition and subtraction around that term, which is what we did first in solving equations before. And then we're going to undo any multiplication or division around that particular variable. Okay? It's the same steps. It's just going to look a little bit different. Excuse me. It's just going to look a little bit different. Okay? For example, this. We want to take this, and hopefully you recognize this as a linear equation. Right? This is what you used to graph lines with before. And we'll do that again this year soon enough. But we want to solve this equation for y. So the first thing I want to do is identify the term that has the y in it. And right there it is. It's that guy right there. So is there any addition or subtraction that we have to undo first? The answer to that is yes. We're adding to this right now 4x. So I want to zero that out. I want that to go away. Excuse me. So I'm going to subtract 4x from both sides, because that will zero out the 4x here, leaving me 0 plus 2y, or 2y. And then notice over here, 8 and negative 4x. You can't combine them. They're not like terms. One has an x on it, one doesn't. So we're just going to bring these down and make this negative 4x plus 8. Then we go back to our term that has our y in it, because that's the variable we want to get by itself, and realize that we also have to undo the multiplication there. We undo multiplication with division, so we're going to divide by 2, divide here by 2, divide here by 2. Let's divide out. We get 1y, or y. Negative 4 divided by 2 is negative 2. We can go ahead and divide those out, and 8 divided by 2 is 4. So we end up with this. So that bottom literal equation means the exact same thing as the literal equation that we started with. They mean the same, they just look different. Okay? We need to really get familiar and comfortable with the idea of solving for y in these linear equations. We're going to do it a lot. Okay? But that's the idea behind rewriting a literal equation. All right? Okay? Now try this one. Think about this one for a second. I'll let you kind of think about it, and then we'll slowly walk through this guy. We want to solve this equation for p. So what are we going to do first? Well, we're going to go find the term that has the p in it, which is this guy. Undo any addition or subtraction around it, which means that I need to undo this addition. So I'm going to subtract 2m, subtract 2m. Those will add to 0, giving me 6p plus 0, or 6p. And then again, we cannot combine the negative 2 and the negative 2m. So we bring the negative 2m down, and then the negative 2 comes down as a minus 2. Then we're going to undo the multiplication that's next to the p by dividing by 6. Okay? That leaves us with p equals. Now we can reduce the negative 2 over 6 to negative 1/3 with the m in the numerator here, so negative 1m minus 1/3. And if you really wanted to, you don't even have to write that negative 1 next to the m. Just make it negative m over 3 minus 1/3. A couple different ways you might see that. And we're done. Okay, there's actually less work involved by solving these literal equations. Okay, try this one. Solve this one for w. I'll give you a second, let you think about that. So work it out, and then we'll see how you do. Okay, how'd you do? Here's our term with the w in it. We're going to undo, or we're going to zero out the negative 3r by adding 3r. So those add to 0. 0 minus 2w is negative 2w. And then we get 3r plus 6. Then we're going to divide through by negative 2. So we get negative 3/2 r minus 3. Okay, done. One more for you to try. Solve this guy for w, and this is the perimeter of a rectangle. You're going to see this literal equation a lot, so get real familiar with using this guy. But solve it for w. Stop the video, start it back up, and see how you did. Okay? Did you get this? P over 2 minus L equals W, and you can kind of see how it went. Okay, so hopefully that's okay. Now, some other formulas that might have you looking at what you're doing and questioning whether you're doing it correctly or not, but we're going to trust ourselves and trust that we are doing this correctly. Okay? We're going to solve this literal equation for R. Okay? So this literal equation is the circumference of a circle. Now, again, we're going to identify our term with the r in it. There it is. Now we're going to look. Do we have any addition or subtraction around that term that we need to undo first? The answer is no. So instead, we're going to undo the multiplication. 2 pi, both are being multiplied into that r. So I'm going to divide by the 2 in the pi at the same time. That's perfectly fine. Okay? And so we get r on this side, and then we get c over 2 pi, which we cannot divide out, and so we just leave it alone. That's it. That's all we've got to do to solve for r. Why do we do this? Maybe we want to find the radius of a circle and we have the circumference already, so we can just plug the circumference into this bottom literal equation and be able to solve it and then find r that way. Okay, just may eliminate some work and some steps later. Okay, solving this one for b, number 6. This one's a little trickier. It's got this 1/2 out front. Okay, so what do we want to do? Well, here's our term with the b in it. We want to get that b by itself. Well, from our last class, when we see a fraction in an equation, hopefully our first reaction would be to clear that fraction, right? I'm going to multiply all of this block, right? Because that's all being multiplied together. I'm going to multiply that block by the least common denominator that I see, which is a 2. If I do it over there, I've got to do it on this side to keep my equation balanced. When I do that, I'm going to multiply 2 times the numerator, 2 times 1, which is 2. 2 divided by 2 is 1, and so we just get BH over here. 2 times A is 2A. Okay, now, I still have to get B by itself, and it's being multiplied by H. So to undo that multiplication, I'm going to divide both sides by H. And so I get B equals 2A over H. And this literal equation means the same thing as this guy up here. It just looks different. Okay, but we solved this one for B. A little weird, I know. Because now we have an A and an H that we can't do anything with. Sorry about that. Can't combine like terms, divide them out or anything. Okay? All right, 7. Solve this one for R. What are you going to do here? Take a second, think about it. Try it, and then start the video back up and see how you do. Okay, well, here's our variable. All right, so we want to solve for R. There's our term with R in it. There's no addition or subtraction to undo first, so I don't have to worry about that. Instead, I have to undo that multiplication. I'm multiplying by t, so now I want to divide by t. So the t's divide out there. The d and the t I can't divide out, so I just leave it like that. And we're done. Okay? All right. Now, like I said, why are we doing this? Well, because if we isolate one of the variables, then we can plug in values for the other ones and just be able to do some arithmetic. Okay? So, for example, this guy. I want to solve this particular literal equation for m, and then find the value of m for each value of n. All right, first things first. Solve the equation for m, right? Well, here's m. There's the term with m in it. I need to undo the addition around that term, so I'm going to subtract 3n from both sides. And so m is equal to negative 3m plus 7. And now I want to find out what m is for all these values of n. Right? Negative 2, 0, and 1. I'm going to find out negative 3. I'm just going to literally plug in negative 2 for n. That's 6 plus 7, which is 13. I'm going to plug in 0 for n. Negative 3 times 0 is 0. 0 plus 7 is 7. And then I'm going to take negative 3 times 1 plus 7, which is going to be 4. And there are your values for m, 13, 7, and 4. It's kind of like our domain and range stuff that we did with our functions. Okay? Make sense? Try this one. Think about it for a second. And then we'll walk through it together. Okay. Solve it for m first. So here's my m. I need to undo this addition first. So I get negative m equals negative 4n plus 4. Sorry about that. Can't combine those two terms. Now I have to divide by negative 1 because there's a negative on that m. Negative m divided by negative 1 is positive m. That's what I want. So this becomes 4n minus 4. Right? So now I'm going to do this n-m chart, where n is negative 5, 1, and 3. I'm going to plug in negative 5 for n. Get 4 times negative 5 minus 4. 4 times negative 5 is negative 20. Negative 20 minus 4 is negative 24. And the same thing here. This becomes 0. And this becomes 8. Okay? That's all there is to it. All right. Try this one all on your own. Solve the equation for m first, and then find the values of m for each value of n. Stop the video, get it done, and then start it back up and see how you did. All right, did you get this? So your equation, m equals 2/3 n plus a half. And then we're going to plug in negative 303 for n. And when you do, you should get negative 3 halves, 1 half, and 5 halves. So if you didn't get that, make sure you come find me during STAR, after school, whatever, and we'll go through it. Okay? All right. A couple quick story problems for you. The formula A equals LW gives the area of a rectangle given the rectangle's length and width. Solve the equation for W. What is the width of a rectangle with a length of 14 centimeters and an area of 161 square centimeters? So first things first, I want to take this literal equation, this formula, and I want to solve it. It says solve the equation for W first. Well, there's my term with the W in it. There is no addition or subtraction to undo. So I'm just going to undo the multiplication by dividing by L. And so I get W equals A over L. Now plug in what you know. The area is 161 square centimeters and the length is 14. So if I want to find the width, all I've got to do is divide the 161 by 14. Okay, let's see, we want to try to reduce this. So you can divide these both by 7. This will go 2 times. This will go 23 times. So you get 23 over 2, or you can go 11.5 centimeters. Right? So the width of the rectangle is 11.5 centimeters. Okay, and again, that's kind of the point of solving these literal equations. Okay, try this one, this last one. The formula P equals 2L plus 2W gives the perimeter of a rectangle given the rectangle's length and width. Solve the equation for W. A rectangle has a perimeter of 182 inches and length 52 inches. What is the width? Stop the video, solve the equation for W first, plug in your numbers. Excuse me, and see what you get. You can start the video back up and see if you're right. And there you go. The width is 39 inches. Did you get that? If not, again, come find me, and we'll definitely walk through it together. Okay? All right. And that's it. This is not going to be your homework. Your homework is out in Canvas. Make sure you have that done by next time.